Okay guys, let's take a look at what our next problem seems to ask. Alright, so over here they're giving us this complicated complex variable problem, and they're saying reduce this into the trigonometric form z equals r cos theta plus I sine theta. Now this is definitely one of the questions that we can show you a whole bunch of tips and tricks for and simplify it drastically. Some of you guys that have tried this problem know how difficult this problem may be, but we're going to simplify this even more than we did the other complex problem where I showed you how to convert this into polar form using your calculator. I'm going to show you guys how to do some math in polar form, and that's going to drastically simplify the way we can solve this problem instead of applying all of those theorems of, that you've learned about powers and roots. So the very first thing you want to do for every one of these types of problems, anytime you're given a complex expression a plus ib, you want to convert this into polar form. You want to find the corresponding radius and the corresponding angle. Of course, the way to do this is to apply these formulas. So we'll do this once, but remember, I've showed you that your calculator does this for you. First, let's show the work. Let's pick one of these over here. Let's take the first one. We have currently, let's say z1 is equal to the square root of 3 plus 1i. Now, if I want to find the radius, it's simply a matter of squaring both coefficients and taking the square root. So if I square the square root of 3, I get 3, plus the coefficient of I is 1, so squaring 1 gives me 1, and the radius here is simply equal to 2. Similarly, we can calculate the angle theta by taking the arctan. Now, this is another way of writing arctan of b over a. So this formula is not typed in correctly. Understand it is b divided by a and not a divided by b. It should be right in your notes though. So b is 1. The number in front of I is 1 divided by root 3. So 1 divided by root 3. Now, you're going to do this in your calculator, and you'll discover the answer. And understand that when you do this in your calculators, it only gives you the correct answer, guys, like 50% of the time. So you have to be mindful of that. Understand that you're going to have to fix your answer the majority of the time. So we got 30 degrees. And in these types of problems, we kind of always want to work in radians. So we know that in order to convert from degrees to radians, it's a matter of multiplying by pi and dividing by 180 every time. So if I want to convert this into radians, slap on a pi and divide by 180. Simplify this just a little bit. And now you have, your angle in radians. Now I know that this is the correct angle because I'm going to take a look at the signs of my a and b values, and that'll tell me whether the answer is correct or not. In this particular case, both a and b are positive values. So I realize that if a is positive, it's like saying x is positive and y is positive, right? So if this is your a axis or your real axis, and this is your imaginary axis or your b axis, a positive and b positive, make sure that you are there. And if you're there, you're okay. However, imagine if you had z equals negative root 3 minus I. Now, if I took these values, negative 1 and negative root 3, understand you would get the same answer because the negatives would cancel. And that answer would not be correct because if they're both negative, then your angle is over here somewhere. It should be actually 180 degrees plus the 30 you find. It would be 210 had both of our constants here been negative. Anyways, we've talked about this already. You guys have an idea of how to fix the angle. And of course, we need to do this for each one of the 3 complex numbers that we have here. Now, in order to save some time, let's just use our calculators to get the job done. So we've done the first one. We know that this is equal to 2. And we know our angle is pi over 6. And I'm going to show you a new way of writing this expression. We're going to write it in polar form like so. So we're going to write that same value as 2e to the I pi over 6. Okay, and we'll talk about that in a minute. So using our calculators, we're going to convert the other two. So if I take root 2 and negative root 2, so root 2 and negative root 2, and my calculator will spit out 2, and it spits out negative 45, which of course I convert, and I get negative pi over 4. And writing it in polar form, I will write 2e to the negative I pi over 4. And if I apply this to the last one, so I have now negative 1 divided by 2, and I have root 3. Oops, not the cube root. Let's try that again. Root 3 divided by 2. So negative 1 and root 3. So working this out, we get a radius of 1. We get theta equals to 120. Remember, you're going to slap on a pi and divide by 180. So that's going to give us 2 pi over 3. And converting it into polar form, we get 1e to the I 2 pi over 3. And what we've done effectively is taken each one of our values here in rectangular form and converted it into polar form. And I'm going to show you guys, well, now the one big trick we've already learned is how to do this business in our calculators instead of having to do that. And the second thing we're going to learn is how we can use these values instead of these ones to quickly solve a problem as complicated as the one we have. Before we get there, here are a bunch of rules that you should know. We've just finished learning how to take something like this and write it like this. Now, if we can take every value and write it like this, here are 3 properties that you should start becoming familiar with. The first one is that if I divide two things that are in this format, that amounts to dividing the radii and subtracting the angles. If I multiply them, I'm going to multiply these terms and add the angles. And if I have something raised to the power of n, then this n, our number is going to get raised to the power of n. Our angle will get multiplied by n. If we understand these 3 rules, guys, take a look at how easy this problem is going to become. It was once a very difficult problem. Let's see what we are going to do with it. So, first things first, I'm going to rewrite this in polar form. Remember, for the first one, r was 2. In fact, in polar form, it's 2e to the I pi over 6. This, and that's an e, let's make sure you guys can see that properly. This and this are equivalent, guys. The next one was 2e to the negative I pi over 4, and this is raised to the power of 7, right? Our second term is 2e to the I pi over 4. There it is, raised to the 7. And our bottom one is 1, which I don't need to write. So simply e to the 2 pi over 3i, right? So e to the 2 pi over 3i. And this guy is raised to the power of 5. Now simply ask yourself, which one of these guys can you apply? So over here, we will notice that we can apply this guy right there, right? If you have an outside power, your number gets raised to the power and your angle gets multiplied by that power. So I want to apply this rule both here and here. Let's do that. So if I apply this rule, I will get the following. The first term is going to remain intact. This is going to be 2 raised to the power of 7. And the angle will get multiplied by 7. So I'll have negative I 7 pi over 4. It's as simple as that. Similarly, on the bottom, this is going to be 1 to the power of 5, which is just 1, so the 5 simply gets multiplied in. So we get e to the I 10 pi over 3. And now we can do pretty much everything else in one step, guys. Remember, if we are multiplying, these guys get multiplied and the angles add up. If we are dividing, the r's get divided and the angles subtract. We can do all of that in one step. Let's deal with the numbers first. So let's multiply and divide our numbers. So I'm going to have 2 times 2 to the power of 7 divided by the number down here, which is 1. Now let's deal with the angles. E to the I, open bracket. Since these two guys are being multiplied, the angles are simply going to be added. So pi over 6 plus negative 7 pi over 4. And I'm going to subtract this angle, so minus 10 pi over 3. All in one step. So all we got to do here is each piece in our calculator to kind of get our final answer over here. So if I work this out, 2 times 2 to the power of 7, essentially 2 to the power of 8, it's going to be 256. E to the I. And now I'm going to work all of these guys out. So 1 over 6 minus 7 over 4 minus 10 over 3 gives us a grand total of negative 59 over 12. And that's it, guys. Now what they want us to do is write our answer in that format. That format simply requires we have r and theta, and we have both of those. Our r is 256, theta is 59 over 12 pi. Final answer here, z equals 256 cos of 59 pi over 12 plus I sine 59 pi over 12. And there you have it, guys. A much simpler way to solve this type of a problem. Step 1, convert each one of these into polar simply by using your calculator. Number 2, know these 3 rules and simply apply them. It is as simple as that, guys. Practice this problem one more time. It is as challenging as it's going to get. Hopefully that was helpful. Let's move on to our next problem.